Okay, so yeah, happy Friday. It's it's week 8 Friday. So next week is like Thanksgiving week, okay? And so I imagine some of you will go home for the weekend. I imagine. Okay, I don't know. I don't know what's gonna happen, but well, anyway, try to get as much as you can done on the group project. When you do decide to depart and split ways for the weekend and things like that, you should have a clear idea of what people are responsible for and working on, and obviously you want to do it in such a way where you can kind of bring your work back together and whatnot, and then we'll have 10th week and final presentations. And so I guess I'll have a sign-up sheet ready to go, and your groups can sign up for when you guys want to present to me, and we'll have that. I was not going to make anybody kind of view other people's group presentations, but I don't know, do you guys want to see each other's presentations at all? Maybe if we should, everyone's shaking their head, okay. Like subtle shakes of their heads. Okay, that's fine. It can just be your group and me. And that will be that, okay? I've put a couple recommended courses here on DataCamp, and I don't know. I've decided to kind of just lay off on the homework, but yeah, question. I was thinking it'd be in person. I suppose. Well, let's plan for in person, okay? And then if for whatever reason, maybe one or two of you can't. We'll just say one person can't come in person and has to join via Zoom. We'll allow that. I'll bring like my iPad and they can join, kind of in a separate window or something. But let's plan for it being in person, okay? I've put in some recommended DataCamp courses, courses that cover regression and basic classification. And when you look at the model projects, their modeling section is really complex and stuff like that. And we just haven't covered anything of that complexity there, okay? But I do think using a little bit of regression or maybe a little bit of a classification method could be helpful at just kind of a basic level, and just try it out. And if things don't pan out, if you can't find a great model, that's also okay. Most of it, I want you to focus on using dplyr to get kind of different summary stats, and using ggplot to do different visualizations. That's really, I want you guys to kind of develop the skills and the insights to be able to explore your data that way. I've decided to lay off on actually assigning these as homework assignments. I hope that's not a mistake. I hope some of you will do this, but again, I don't know what your exact data looks like. And so for some of you, if your value that you're trying to kind of predict or model is numeric, you would use regression. And if it's categorical, you'd use classification. So I'm not actually assigning these. And I'll just kind of ease off on assigning homework, and just to kind of make sure and give you guys time to work on your projects. That's what I want you guys to focus on. Okay? Any questions about, I guess, the remaining class time? And I welcome any comments and feedback and suggestions regarding, I don't know, what you feel you've learned in the course, and what would make the course, whether it has met your expectations or if you expect something different or something like that. Just because, again, this was kind of the first time, and this is really the first time we're bringing in this exploratory data analysis heavy course to kind of at the intro level for first years and things like that. A lot of times we we give you a whole bunch of, we spent a couple weeks on, probability and t-tests, and, classical statistics courses focus like almost the entire time on that kind of content. And here, we just bring a quick time to that, and then, most of it is spent on this kind of thing. So well, anyway, so more stuff, data visualization in ggplot. I also took Monday's content, and Monday's content I kind of formalized into a series of slides as well, okay? And the key is to kind of pay attention to how one set of instructions has changed from one slide to the next to kind of detect how things have gone different, okay? And I guess let me upload this set of slides as well. Today's set of slides, even more ggplot. We'll bring that in. All right, so I want to explore categorical variables / proportions, okay? So here, I'm taking the diamonds data set. The diamonds data set, I want to show you just the different proportions we have of the different cut types, okay? So we have, from best type of cut, ideal, down to the worst type of cut, which is fair. You can see the biggest category is ideal, and over half are ideal and premium, okay? Now, how did I do this? This is using a geometry called the column, okay? It's very similar to bar, okay? Geom bar and geom column are similar, except the geom column, with bar, you don't have to specify a vertical value, okay? The geom bar will automatically count up the categories, okay? If you say geom column, you can set y equal to the total, and it will take the total numbers and kind of continue stacking them up, okay? And so what have I done? First, I've done dplyr stuff, right? I took diamonds, I grouped by cut, and I created a summary table where I used just the total count of that group, okay? And so this part just has two columns, right? The cut, ideal, and the total, which will be how many diamonds have that cut, okay? The cut, premium, how many have premium cut, so on and so forth. And then we pipe that result, okay? So this is one of the cool things about the tidyverse, is you could take your summary table and store it somewhere and then run ggplot on that summary table. But here you can also just pipe the resulting summary table into ggplot, okay? And one thing to remember is that when you do ggplot, the different aspects of ggplot you combine with a plus, whereas when you're using dplyr, you pipe things using the pipe, okay? So you're gonna switch from the pipe to the plus once you're in ggplot, okay? So anyway, with ggplot, we got x equals 1, y equals total, fill equals cut. So x equals 1, what does that even mean, okay? We don't actually want to plot any kind of information on the x-axis, right? We just, here really it's a column. The only vertical information that's of interest to us is the type of cut, okay? And so this is what we have. So this will do that, right? Does that kind of make sense? Geom col. Now, one thing you can do is this is the exact same information here, and the only thing I'm going to add now is I'm going to do coordinates polar, okay? Coordinates polar, and I say take the theta, okay, that is the angle on your polar coordinate, and transform the y, right? The y is the total. Transform that into the angle, okay? And now we have a pie chart, okay? Sometimes pie charts are handy. Sometimes they're not that great, okay? But here's one way to do it. Okay, so you can do, basically you take this and you say take the y-axis, which contains the total information, and transform it into the angle. And now you have a pie chart. Okay. Now, unfortunately with the pie chart, the default ggplot settings has kind of the gray background, and then it puts in the axis information this way. Okay, and it just puts some other stuff. You can get rid of it by adding theme void. Theme void just says get rid of everything. And now you have a bit of a cleaner pie chart. Okay, so again, what does all of this look like? We're summarizing it. We create a column plot, and then we do a polar transformation to get ourselves a pie chart. If you want a pie chart, yeah.
I don't really know what's on the x-axis.
Yeah, there's nothing of value on the x-axis. Okay, there's nothing except I think we run into problems if we don't specify an x-axis, and so this is just kind of like a dummy value. Okay, that nothing. We're not actually plotting anything from the data. Okay, but we do need to position. So when we do the column, we do need to position this column somewhere along the x-axis. Okay, so I don't actually want to. I don't want to like separate the data along the x-axis based on some variable that I have. Okay, so I'm just kind of saying put all of the values in one position on the x-axis, and so I'm just picking an arbitrary value of 1. I could have picked 2. I could have, it just says, because if you imagine you're plotting something, and you've got an x-axis, you've got a y-axis, and they're asking, hey, where should we put this? And you're just like, well, anywhere. Okay, but they say, well, where? I don't know where anywhere is. So you just say, just put it at 1. That's all we're doing here. Okay, we're aesthetically mapping as far as where should the data go. We're just saying put it. As far as the x-axis position, we're putting it at 1. Okay. I don't know if that clarifies. And so this thing is like, what does this even mean? This means nothing. Okay. Here is so if I did summarize total equals n, it would have just been these two columns, the cut and the total, and then here I'm adding another column for percent, okay? And I'm rounding it off to the nearest whole number, okay? So I'm saying mutate percent, round, multiply it by 100, do this column total, divide it by the sum of the total. Maybe I should have called it count and sum of the count or whatever, okay? So if I added this all up and I divided, then here we've converted these into a percentage, okay? Whole number percentage. And the percent, when you have the percent plot, you can create something, you can create something called a waffle plot. A waffle plot is kind of, also shows you proportions, but in a grid, and you'll understand why it's called a waffle plot in a moment. So in order to use the waffle plot, what you have to do is you have to create a vector. You can't, it's not a ggplot thing, okay? It's not ggplot, so you have to, in order to use waffle, you have to just extract this column, okay? So right now, I took that table and I'm throwing it into something called summary table. And from summary table, I'm pulling out the percent column. So I'm doing summary table percent, okay? And that's just that one column. And now I just get the counts, 3, 9, 22, 26, and 40, okay? So it's just this column 3, 9, 22, 26, 40. And that's this, okay? And what I'm gonna do is I'm going to add names to the vector. So I'm saying name the counts, the 3, 9, 22, 26, 40. And what are you gonna use as the name? Use the names found here in cut, Okay, fair, good, very good, premium, ideal, and that's what we're doing. Fair, good, very good, premium, ideal. Okay, so this is how the data needs to be formatted to use the waffle plot. Okay, so I'm going to take this vector, this named vector, and you have to load up. You might have to install a library called Waffle. Okay, and then it creates this plot, which is called a waffle plot because it looks kind of like it's a waffle, and it's colored in. It's like the boxes are shaded in based on the categories. Okay, and so here the total number adds up to 100, and so we can see, oh, okay, yeah, 40 of them are ideal, and this looks like 21, 2, 3, 4, 5, 6. 26 are premium. 22 are very good. 9 is good, and 3 fair. Okay, and so it's another way to kind of present percentages and proportions, but in a way that you can kind of count them, right? Whereas back here, same information, but if I ask, well, how different is premium versus very good? I don't know if anybody would be able to tell me, right? Just by looking at this, you can't really tell. But with this, you can actually kind of quantify if you wanted to count them out. And I think we're rather accustomed to counting little grid boxes of 10. So a waffle plot's another way of kind of visualizing proportions of different categories in your data. But it's not a ggplot thing, okay? You have to feed in your data as a vector with names on it. Okay. Let me go ahead and give you your first view quiz answer. First view quiz answer today is A as in apple. A as in apple. Okay. Now in your model projects that I've given you, nobody had like a waffle plot or things like that because I don't think matplotlib in Python supports this kind of stuff. So you have different kinds of plots, but you know, there's lots of ways to effectively demonstrate, visualize your data. Okay. I think ggplot really has a very nice arsenal of tools that can be used though. Okay. What if we want to look at multiple categorical variables? Okay, so this time, not just here I'm going to put the counts on the vertical axis, and then we're going to have the clarity. So we've got the cut, and now a second categorical variable, clarity, okay? And there's like lots of different clarity grades for diamonds. So I just picked 4 of them. I think these are 4 of the most common clarity grades. I think the best possible clarity grade for a diamond is internally flawless. Internally flawless, but those are very, very rare, and don't there aren't very many. So more common are clarity grades of, you know, slightly included and very slightly included and things like that. And these are the different things. And so here I just said put X on the clarity on the X-axis. We'll take, and I didn't even specify the cut, okay? I said change the color by cut, okay? And geom_bar says, okay, well, I'm just going to go through and just try to count everything up for each of these clarity things. And it says, okay, this is how many I counted for clarity SI2. This is how many I counted for clarity SI1. And so I didn't specify a Y because here I'm using geom_bar. Okay? Now, because geom_bar will go through and count things up. If you wanted to use geom_column, you could, okay? Or if you wanted to specify, I'm sorry. So geom_bar will count them up, okay? But if you wanted to represent them as proportions, okay, you would need to go back to geom_column, and you have to kind of create a summary table here, right? So this time, again, I'm filtering it down to just those 4 clarity grades, and we're going to create a summary table where we've grouped by clarity and cut. And so we say, okay, this is how many slightly included 2 fair diamonds we have. We have a total of 466. I said total, give me n. Okay? And then this is how many SI2 good diamonds we have, 1,081. SI2 very good diamonds, 2,100. SI2 premium, 2,949. SI2 ideal, 2,598. Now that information is all included here, right? So the height of this thing is 2598. SI2 ideal, this has a height of 2598. And if we were to count this, it would be 2949 and things like that. But here we've put it into a table, okay? We've grouped it, we have two groups, grouped by clarity and cut. And there are, I guess, a total of 20 rows here, okay? Total of 20 rows. And here, we're going to take this resulting table, and we're going to say plot, put clarity on the x-axis, take that total column, this number, 466, and put it on the y-axis. We are going to color the fills based on cut. Okay, so we want to change the color based on cut. Okay, and this time, as far as the column goes, we want to go from, we're going to scale them all up so they're at the same height. Okay, so here we have different actual heights because there's different counts. There's more SI1 diamonds than there are VS1 diamonds. Okay, but if you wanted to kind of compare the proportions, like if I said what proportion of SI1 is ideal versus what proportion is VS1 is ideal, it's hard to tell because they have different counts, right? So if you wanted to compare the actual proportions, you need to scale everything up to 100% or proportion of 1. So here I can do geom column position equals fill, and now we can see the actual proportions here. Okay. So do we see that? So basically, these are presenting very similar information. This one, the heights are the total counts, and here all of the heights are set up to 100%. Okay. We could also have done this, in a few different ways. We could have created a column where we went and calculated the proportions by group and things like that. But this is just one way to do this, which I think some of your data sets will, I think, lend itself nicely to this format of graphic to kind of compare proportions across different groups. Okay. Any questions on this? Or if you wanted like changing options and stuff. All right, I guess I'll give you your second view quiz answer. Second view quiz answer today is E. E as in elephant. E as in elephant. Okay. So a lot of these things do require the combination of dplyr and ggplot. Okay, these two things kind of work together. You use dplyr to kind of get your summary tables. You use ggplot to visualize the result. Okay. Are we starting to feel good about creating summary tables and stuff in dplyr? Getting good practice there. I truly think that's like one of your most important kind of base building block for data exploration. Okay. All right. Let's talk about numeric distributions. This is stuff we've already seen. So here, I'm just taking the numeric variable, the price of the diamond, okay? And I'm creating a histogram based on this, right? So I just take the diamonds data set, we're gonna map price onto the x-axis, and then we say make a histogram. And so when you call a histogram, you don't need to specify anything for the vertical axis. It just does this. So we've already seen histograms before. Okay, so one thing you can do is you could say, hey, what if I want to look at this, but for different, split it up by some categorical variable, okay? And so here, I'm going to do x equals price, And one thing I can do is I can wrap it, put it inside a facet grid, and say take the clarity variable and do that, okay? And so now I've got a histogram for internally flawless, histogram for very, very slightly included, very, very slightly included 2, very slightly included 1, very slightly included 2, slightly included 1, slightly included 2. Okay, and this is what we see for the histograms. Okay, this is kind of too many. This plot isn't that great. All right, it's just there's too much going on. Okay, so you got to kind of think, right? So this is not a great plot. Okay, it could be maybe a little bit more compelling if we just filtered it down to maybe a few of these clarity grades, but as it is, there's 8 different clarity grades, and it's just a little bit too much to fit in one plot. Okay. Okay. So here's a here I decided to change the variable. Instead of clarity, I'm doing cut. Okay, so we've got ideal, premium, very good, good, and fair. And then I've decided to, instead of doing a histogram, do a density. Okay, and so a density will give everything an area of 1, whereas the histogram, it goes straight off the counts. So here we don't have very many included 1. This is like the lowest grade of clarity. We don't have very many. If we were to change it to a density, it would have kind of inflated it so it has a total area of 1. And all of the things would have a total area of 1. Okay, so this is one thing you can do. And here I also said, hey, let's alter the fill color just to kind of make it a little bit more pretty or interesting. Okay, still it's wrapped in a facet grid. Okay, what we could do is we could take this and also make a box plot. So here I'm going back to the clarity grades, and we can say, well, what if we make a box plot based on the clarity grades? Okay, so now I've got 8 side-by-side box plots, and these are the different clarity grades. And right now we look at this and we say, it doesn't look like there's much of a relationship between price and clarity. Okay, what do you think's going on? Because the rule is higher clarity diamonds are supposed to cost more. Internally flawless diamonds are supposed to cost a lot more than slightly included diamonds. But it's not being reflected when I do these box plots. What do you think's going on here? Yeah. Yeah, the size of the diamond, right? There's other factors that go into the price, not just the clarity grade. There's other things. And so as you explore your data, okay, it's going to be important that you don't just look at one variable at a time. You might have to look at something. Okay, there's something known as Simpson's paradox. Okay, and it's a little bit like this, where we know, right? And this is where your domain knowledge comes into play. Okay, your domain knowledge comes into play because just our domain knowledge of diamonds says, hey, internally flawless, this is the highest grade of clarity. Okay, these are the most precious types. And when we're looking at this box plot, we're seeing that the median price for internally flawless, given by this vertical bar here, is lower than the median price for very slightly included 2. Okay, which doesn't make sense. Okay, and we say, oh, well, you know what? There's other aspects playing into this. One of them being the size, or whatever it is, the carat size of the diamond. And so what we might say is, hey, you know what? Let's limit ourselves to just diamonds of a certain size. Okay? And if I do that, then the relationship that I'm expecting appears. Okay? If I say, let's limit ourselves to just diamonds that are between 0.95 and 1.05, so diamonds right around 1 carat, okay, which is a very popular size diamond, okay? 1.0 carat, it's kind of like, I don't know. there's like a certain threshold, right, where you're like, okay, I want to get at least a 1 carat diamond or something. Again, if you even buy into the idea of diamonds in the first place, which there's a lot of questionable market practices there. But anyway, if we limit ourselves to just one size, okay, now we see the relationship that we're expecting. We're expecting included diamonds, low clarity diamonds, to have low median prices, and as the clarity improves, indeed the price goes up and up and up. Okay, and so the relationship that we were expecting emerges here. Okay, and here I'm just doing geom box plot. We're putting X on the price and clarity on the y-axis there. Okay, does that feel okay? Okay. There is a package called GG Ridges. GG Ridges. All right, and this takes the same data here, and rather than a box plot, and box plots are nice, okay, but you can also convert it to densities, all right, and you can see right here exactly like where these things are centered. It's the exact same positions here, right? We're going straight from here to here. This is GG Ridges, and it's plotting density plots, and these are called ridge density plots because they kind of overlap on top of each other, which is kind of like the stylistic effect, but it's also kind of pretty, looks kind of, I don't know. So this information and this information are the same, right? So when you create your report, you would pick one, okay? Don't do this and this, okay? That's like redundant, right? So pick one of these things, and I would maintain, as a group, you'd say, hey, do we want to go with box plots? Do we want to go with ridges or something like that? Try to make a decision, unless there's something very clearly compelling where you want to say, I want to include this and this, because to me it's really, really, really important to show that once we get to very, very slightly included, there now we start to see a bimodal structure here, okay? And it's really important for us to show that, which is lost. The modality is lost when you have a box plot. A box plot really just shows you the median, Q1, Q2, the min, the max, some outliers. It's very much a summary thing, and it's very easy to do quick comparisons, whereas over here it's a little bit harder, but you still see that the modality keeps going up and up and up, okay, as far as we go here. Okay, kind of going on with this, I'm just showing, if you wanted to, you could take this same plot and just add some color to it, all right? And so here I said, fill in the ridge densities, map the variable clarity to it, and here you can specify what palette you want. And here I said palette is oranges, and I gave it a little bit of transparency. Alpha is 0.6, and so these things kind of overlap a little bit and look like this. And as far as palettes go, you just try things out. Go to just type in GG. Go to the reference, I would say, and type in palette. And these are some of the different palette options, okay? You have diverging palettes and qualitative, sequential palettes, things like that, okay? So qualitative is you just want different colors, okay? Sequential would be something where, darker, it goes from dark to light, okay? So oranges is a sequential one, which is the one I've chosen here, where kind of the lowest grade is down here and the highest grade is up here, and the lowest grade is light and the highest grade is the darkest orange and things like that. Okay, so these are just different things that appear. So just play around with it. play around with it, you can decide, you know, I like this color the most, okay? So you've got grays, greens, oranges, and you've got different things, okay? Just try things out. Oh, something happened. Okay, give me a second. All right, I gotta fix this. All right, let me fix my plots here. Okay. Another way of visualizing numeric data. So here I've got a, you know, different categories, numeric data for different categories here. Right? Obviously, if you have two numeric categories, variables, you would do like a scatter plot. But you can also do a scatter plot type thing for, let me see if I can get this to pop up here. So what do I have here? So here, this is kind of a lot going on, okay? So let me just show you the commands. So I said, okay, let's look at diamonds of 1 carat size, okay? And we're going to look at the relationship between price, clarity, and cut. And what am I using to visualize? Because I don't just want, you know, how different grades of clarity affect the price. What I've done is I said, okay, here are the different clarity grades, but I've also taken the dots themselves. Okay, I've taken the dots themselves, and we're plotting every single diamond here. Okay, and so we can see overall, okay, the lowest grade cut is fair and it's red. Highest grade cut is blue and it's ideal. Yellow or this whitish color is somewhere in between. Green is over here. And what we see is kind of overall, and again, there's variation here, but we see red at the bottom and blue at the top, with yellows kind of in the middle and greens close to the blues and oranges closer to the reds. Okay, so we kind of see overall this relationship where you got reds down here and blues up here. And what we also see, okay, is that you got more kind of red diamonds down here, whereas once you get up here, you don't have any red cut diamonds, okay? It's pretty much just very good, premium, and ideal once you get to internally flawless. There are a couple diamonds up here that are good, right? But those seem to be exceptions. And overall, you know, VVS1, very, very slightly included. Also, we also see kind of the upward trend, okay? This relationship that we see, that the price goes up, the median price goes up as the clarity goes up. Also, that relationship shows, okay? And we also just see that there's a lot more diamonds over here than over here, and this is all done with a jitter plot. Okay. Again, there's kind of a lot going on here, and so to kind of make your graph a little bit more compelling, it could be useful to filter down and just say, hey, let's just look at a few clarity grades. Let's look at just a few cut grades. All right, and so for this next plot, it's pretty much the same plot, but I've filtered it. I said, let's take the diamonds that are between 0.95 and 1.05, so diamonds right around 1 carat, but let's limit our cuts to just ideal, very good, and fair. And let's limit our clarity grades to just SI2, SI1, and VS2. So let's just look at a few of the clarity grades. Let's look at a few of the cut grades, okay? There's one more aspect for diamond, that's the color, okay? There's the color of the diamond. You know, some diamonds are like pure white, and some diamonds, you know, are a little bit yellowish and stuff like that. And so that's another aspect that we're not plotting here, but Here's kind of the resulting plot when you look at when you filtered it. And again, you see the relationship where the lower grade cut diamonds, red, are at the bottom, and the higher grade cut diamonds, in this case, which are shown in green, are at the top, and the very good is somewhere in the middle. Okay, but what this captures is kind of the amount of spread that does appear even with diamonds that have the same clarity grade, diamonds that have the same around carat size. Okay, because all of these diamonds are around 1 carat and something like that. You also see this one outlier way out here. It'd be interesting to see what's going on with this one. It could just be something just wildly crazy. Who knows, right? But this is, again, the relationship that overall, as clarity goes up, price goes up. Overall, as cut goes from fair, very good, to ideal, fair is closer to the bottom, very good in the middle, and ideal at the top. Things like that, right? So these are, and we see kind of the amount of spread that shows up here. So these are just kind of potential ways to plot your data that could be compelling depending on the data that you have, right? And so you've got lots of different, everybody's data set is very different. And so what you're looking at, I think there's a lot of kind of interesting relationships to explore. Okay, your last view quiz answer for today is B. B as in bear. B as in bear. Okay, all right, well, that's it for today. So we'll wrap up here. Have a good weekend. Good luck as you guys continue to work on your projects. And again, don't hesitate to stop by office hours, or set up an appointment, or come by and ask for advice or guidance if you're struggling with any aspect, whether it's just trying to get a plot or trying to get some of your code working or something like that. Okay, or advice on the direction to head in for your project. I'm happy to lend you some ideas.